Good morning, class. Coach Day. This set of videos is going to be on elimination. So there's another way to solve system of equations using elimination, and it is a method of solving systems by adding or subtracting equations to eliminate a variable. So it's called elimination because you're going to get rid of either the x or the y, solve for it, and then plug in for the other one. So step one, you got to make sure the equations are lined up. What I mean by that is if it's in standard form, it needs to look like ax plus by equals c over ax plus by equals c. You make sure the x's and the y's and the c's are all over each other, okay? Or if you do this with y equals, which I wouldn't recommend, I'd recommend substitution on that, but you can use elimination. You need to make sure it's y equals mx plus b over y equals mx plus b. The main thing is that you have your x's and y's lined up, so when you subtract one of them will cancels, or when you add one of them will cancel. So step two, after they're lined up, then you can add or subtract the equations to eliminate the variable with the common coefficient. Remember, when I say coefficient, that means the number in front of the variable. So, for example, if we had 3x, the coefficient would be 3. It's always the number in front of your letter. Now, step 3, after we add or subtracted, then you're going to solve for whatever variable remains. Okay, so if you cancel out x, you solve for y. Cancel out y, you solve for x. And then step 4, you're going to substitute your answer into either the original or the other one, and then you can solve for the other variable. So, just like in substitution, when we got like x equals 6, then you plug in 6 into the other one. Or y equals 7, you plug in 7 for y. But you can choose which equation you plug it into on elimination. Alright, let's look at the first example. I've got y equals 3x plus 4 and y equals x minus 2. Yes, I would rather use substitution on this, but I'm going to show you can still use elimination. This has a coefficient of 1. This has a coefficient of 1. It's that sneaky 1. That's 3 and that's x. Well, we're obviously looking at the y's because they have the same number in front, right? Now, how could I get those to cancel? Adding or subtracting? Okay, I hope you pick subtracting because 1 plus 1 is 2, but 1 minus 1 is 0. So we're going to subtract them. 1 minus 1 is 0. 3x minus, and there's a 1x there, 3 minus 1. Now, when we subtract, we've got to subtract each individual part, okay? So 1 minus 1 is 0. 3 minus 1 is 2, so we have 2x. And then 4 minus negative 2, remember, minus a negative, change it to plus. So 4 plus 2, which would be 6. Now, I've got 2x plus 6 equals 0, so I got to move my numbers to the other side. I got to get x by itself, so I'm going to subtract 6. I get negative 6 is equal to 2x. The last step, divide by 2. And I get negative 3 is equal to x. So all I need to do now is take this negative 3 and plug it in for one of those x's. You can choose either. I'm going to show both on this first example, but on the rest I'm just going to show one. So if you get y equals 3x plus 4, and then you plug in negative 3 for x, you get y is equal to 3 times negative 3 plus 4. So y equals 3 times negative 3 is negative 9. And then negative 9 plus 4 is negative 5. So I got y equals negative 5. Now, if I tried it into the other one, the same thing should work out. Y equals x plus 2. And I've got to plug in negative 3 for x. So y equals negative 3 plus 2, negative 3. Oh, sorry, this was a minus. I miswrote it. So x minus 2 and negative 3 minus 2. Negative 3 minus 2 is negative 5. Sorry about that notation error because my original equation was y equals x minus 2. If you don't believe me, rewind the video before I change it to plus, okay? So either way, we got the same answer. After you get your first letter, you can plug it into whichever equation you want. You still end up getting a point if there's a solution. That point, my x value is negative 3, my y value is negative 5. So that is my solution. I'm going to stop the video here. We'll do a few more examples on the next one.